JAMB candidate, the next calculation we have here is calculation under half-life. Half-life. Let's destroy this because you are definitely going to see this in your JAMB UTME. Okay, so this is my number. All right, ensure to contact me on WhatsApp if you need the most repeated question, the file containing the most repeated questions in physics, chemistry, and biology. Okay, in physics, chemistry, and biology, ensure you send me a DM. You want me to coach you for this exam? You know, when you are with the right tutor, things begin to make sense. All right, so ensure to connect with me. This is what the number to connect with me. All right, let's go. We are looking at half-life. The question read, JAMB must repeat question 1. The half-life of a radioactive material is 6 hours. The half-life is 6 hours. All right, we put it here. Half-life. Okay, equal to 6 hours. Okay, what else? They said, what quantity of 1 kilogram of the material would decay in 24 hours? So they're asking us how many part of this 1 kilogram of the material, how many portion of this 1 kilogram of the material go, decay, okay, within 24 hours or in 24 hours. All these are the options provided, everything in kilogram, all right? Meaning, say, if you're losing at 0 point something, all right? So in kilogram and fraction. So that tells you that the answer should be in 0 point something or in fraction, just like they put out for here, all right? The formula of half-life, what will be the formula of half-life? N naught. No. I don't think so. This N naught is for, okay, N is equal to N naught times, this is one of the formula for half-life, 1/2. Now this one that they commonly use for chemistry, N. This one commonly used in chemistry. The other one, now for physics that they use and well for. So this one no join. So this formula for half-life when you are working in chemistry most of the time, now this one you need, where N is equal to the number of what? Half-lives. This thing get formula with the calculator more. The formula of half-lives, okay? And the formula for this number of half-lives is total time over half-life. Remember, say for the question, they give us half-life, okay? Total time over half-life. That be the formula for this number of half-life, okay? Then N, capital letter N is equal to what? Remaining quantity or remainder. Remaining, okay? Pardon that spelling, remaining quantity. Okay, or the remainder. Okay, now this one. Then this N naught is what? Waiting UBC, the initial quantity. The initial quantity of the what? The substance or the radioactive substance. Okay, so since we want to apply this formula, we have to find this number of half-lives because it wasn't given in the question. Okay, number of half-life wasn't given in this question. They only give us the half-life of the radioactive material. They only give us half-life. But they don't give us the number of half-life. So we know if we apply this formula to get the, the fraction will remain. Okay? So what we go do now, say we go first of all find the number of half-lives. Okay? Number of half-lives is equal to waiting. This formula that we go apply. And what does the formula say? Total time. What's the total time? It says the half-life of a radioactive material is 6 hours. Okay? So that tells you that this is what? Wait, is 6 hours. Okay, this one is the initial half-time. What quantity of 1 kilogram of the material will decay in 24 hours? So the total time is 24 hours. Okay, so 24 hours over half-life. This one is the half-life. See, the half-life, 6 hours over 6. 24 divided by 6 will definitely give us 4. Okay, 4. So this is 4. The number of half-lives, which is that small n, is equal to 4. Okay, so let's see if we can apply this formula to solve now. Okay, we have n. We have the initial. Okay, we have the initial. So we can use this formula now. We have everything. Okay, so n is equal to n naught times 1/2 n. Okay, since we be saying that this n we define, now we want to calculate what's the remaining fraction or quantity. Let's use quantity. Okay, the remaining quantity, that's what we are calculating, applying this formula. N stands for what? The remaining quantity, the remainder. All right, NO now waiting, the initial. Okay, the initial. And that initial now waiting. I think that initial will be taken as 1. The half-life of a radioactive material is 6 hours. What quantity of 1 kg? The initial is 1 kg. Okay, it's 1 kg. So 1 n is equal to 1 times 1/2. Okay, bracket 1/2 bracket n raised to power 4. So what is this going to give us? Anything raised to power 4 for mathematics, according to law of indices, we're going to get n is equal to 1 times 1 raised to power 2. It will come here, everything within inside the bracket will come square over 2 raised to power 2, which will now give us what? 1 times 1 now within 1. Okay, 2 times 2 now within 4. Everything times 1 will still give us the same thing. So we'll get 1/4 here. So n will be equal to 1/4. All right. Was this well solved? No, this is wrong. It's raised in power of 4. There's a mistake here. Let me bring the fresh paper so that we can continue from there. Okay, so we were left with n equal to 1 times bracket 1 over 2 bracket close 4. Okay, so we have to solve this now. Solving this, everything in this bracket, we will apply this 4 raised to power 4 to all of them. That's why we are going to be left with n is equal to 1 times bracket open 1 raised to power 4 over 2 raised to power 4. Okay, we are going to use this one to open this bracket now. This thing, we solve the bracket. This will give us equal to 1 times 1 times 1 times 1 times 1 into 4 places. It will still give you 1. So we are going to have 1 over, then 2 times 2 times 2 times 2 into 4 places. That's something like this. 2 times 2 times 2 times 2 into 4. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So this is what? 16. 16. So this is what we have. All right. So how do we complete this calculation in mathematics? In mathematics, fraction under fraction, if we have something like this, 1 times 1 over 16. What are we to do? We times now. 1 times 1 now with 1 over 16. We are going to be left with 1 over 16. Okay, so this one, so the remainder should now give us 1 over 16. N is equal to 1 over 16 kilogram. So among the options, do we have anything like that? 1 over 16. Okay, option D is 1 over 16. But we are not done solving yet. Okay, we are not done solving yet because they asked us, what did they ask us? They asked us, it said, what quantity of 1 kg? So the quantity of 1 kg that is left. So they are now asking us what quantity of the 1 kg of the material would decay in 24 hours. Since we have decay here, we are going to calculate decay, applying decay formula. Okay, decay formula. Decay is equal to, remember they asked us what quantity of 1 kilogram, okay, of this particular radioactive material will be left after 24 hours. Okay, so decay is equal to NO minus N. Hope I'm correct. Yes, I think so. All right, this is the decay formula. So we are going to apply this. Decay is equal to, what is our NO? The original. The original quantity is 1 kilogram. Huh? 1 minus, what is our N? Which is the remaining quantity, the remainder after decay, which is this. After the half-life, sorry, not after decay, is this one. 1 over 16. 1 over 16. So how are we going to solve this in maths? In maths, when you have something like this, under the law of fraction, you are going to do what? You are going to use the denominator. You put the denominator on both sides. So you are going to have something like 16 minus 1 over 16. Okay, you bring the denominator up. Okay, 16 minus 1 over 16. That's what it's going to be. All right, so you are going to have 16 minus 1 will give you 15 over 16 kilogram. So this one is the decay. Okay, that's what's going to be left. So among the options, we have, yes, we have 15 over 16 among the options. This 1 over 16 is a trap, actually. This one is a trap. So this one is the correct option. Let's move over to the next question, under half-life. Still under half-life, the JAMB must repeat question 2 reads, the half-life of a radioactive substance is 14 days. Half-life equal to 14 days. Okay? If 48 grams of the substance is stored, after how many days will 1.5 grams of the original substance remain? Alright, 48 grams of the substance is stored. Okay? So they ask us, how many days will 1.5 grams of the original substance remain? So, what do we do here? I am going to apply the shortest cut to solving this. Okay? All the options are represented in this. If you say make we follow, they use half-life formula, they solve this thing. I don't get that strength too. And if you solve and not finish, you don't get the answer. So I don't have that strength. So we go use sense. So since they tell us say 48 grams of this substance is stored, after how many days will 1.5 grams of the original substance remain? And the question started with the half-life of a radioactive substance is 14 days. 14 days is the half-life. If 48 grams of this substance is stored, okay, 48 grams is stored, okay? After how many days will, and the half-life was 14 days. 14 days, 1.5 grams. Okay, this is what is going to happen. Waiting they give us N equal to 1.5. Okay, the N is what? 1.5. After how many days will 1.5 grams of the original substance? Okay, N, which is what? The one left, the leftover, the remaining quantity. Then NO, which is what? NO, which is the original quantity, is equal to this 48. If 48 grams of the substance, that's the original quantity, 48 grams. Okay, waiting else they give us. And the question also say how many, after how many days we original. Okay, so they ask us N is equal to, okay, so N now is equal to question mark. All right, so what is going to happen? This 48, let's divide this 48 by 2 until we get 1.5. 48, how many times can we divide 48 by 2 until we get 1.5? Let's find out. If we divide 48 by 2, we are going to get, this one is the first one. We are going to get 48 divided by 2 will give us 24. 24 divided by 2 will give us 12. 12 divided by 2 will give us 6. 6 divided by 2 will give us waiting 3. Okay, 3. 3 divided by 2 will give us waiting. Yes, 1.5. Okay, we don't fit divide them by 2 again. Okay, so this one is the second one, this one is the third one, this one is the fourth one, this one is the fifth one. So it means that we 2 can divide 48 5 times before we get 1.5. So the answer, okay, 5 times. The initial half-life is 14 days. That's the half-life. So let's now times this 5 by the half-life. Let's see. 5 times 14 equal to what? 14 times 5 is what? Because it's this n we are looking for. This 5 is this n, which is number of half-life. Okay, this n is number of half-life. Number of half-lives, 5. Alright? So basically we are applying the formula of time because it's asking us after how many days we are looking for time. The formula of time is T in half-life is T equal to n times half-life. And here they give us half-life, which is 14. N and 5. 5 times 14. Now the same thing we are talking about. Time is equal to this. Okay, so 5 times 14 will give us 70. Equal to 70. So 70 days. This should be correct. Among the options, pick the option 70 days and drop it in the comment section. Applying that formula is going to take a lot of time. Let's move over to the next question.